Hello everyone, happy Thursday. Welcome to another episode of LeetCode Live, where we do daily live streams of LeetCode. We push the boundaries, we try to get to the next level in our careers, we try to hone our skills as engineers, or we're just here to do some LeetCode for fun, and maybe you want to listen to some long form sort of podcast style of someone doing LeetCode. One thing I want to mention before we get started, so let me actually switch my session here. So again, if you've all been following me since day 0, which was July 16th of this year, the first thing I started off with was just daily LeetCode live streams, which is of course what I've been doing for a while now. Let me refresh this page because I don't want that video to show. Okay, so I was doing that for a long time, and I was doing the daily LeetCode live streams as well as the weekly roundups that you all know, and those happen on Sundays now at the end of every week. And then after some time, I thought to myself, well, a lot of people have asked me about JavaScript, and I do consider myself a front-end developer, so why not also make some front-end content? So I created this series called With Vanilla. That's just front-end content specifically made for people that are looking to do things with vanilla JavaScript. No frameworks, no libraries, so on and so forth. So I started doing those. And then as of literally last night, I have heard from the community that they would like to perhaps see some content covering the explore cards of LeetCode. And so I started doing that last night with my first playlist from the LeetCode Beginner's Guide, which is taken directly from an explore card on LeetCode. And my goal is to, on top of the daily LeetCode live streams, also create different playlists that go through all the questions in every single explore card. Now, the difference with these videos are that these videos are only for one specific question. So for example, if you look at the name of this video, running sum of 1D array, the only thing that's going to cover is that one question, nothing more. Whereas with these long form style LeetCode live streams that I've been doing, we cover a wider amount of LeetCode live streams, wider amount of LeetCode questions. You might hear me fumble, you might see me skip a question. It's really more for you just to see like a raw look into my thinking process. Whereas with the Explore cards, you're just getting the optimized answer. There might be some experimentation, but most of the time I've already done the answer beforehand. I've done the question beforehand, and you're just getting the final look at that answer. So make sure to stick around, subscribe to the channel if that's something you're into. I'm going to continue creating more content for the Explore cards, for the arrays and binary trees and strings and all that other great stuff that LeetCode has to offer. So make sure to stick around if you like that sort of thing. Else, let's go ahead and get started right where we left off yesterday. We're right now sitting at 243 questions. So let's go over here to algorithms. Let's go to easy, sort by acceptance, and let's go to page 3. I think the one that we were going to start off with today was 2sum4. Yep, where the input is a binary search tree. I think this is a really good question, and I wanted to save it for today because what I really wanted to do on this one is I wanted to be able to draw our input and then sort of like work from there. So let's start off with this tree, which is a nice tree to work with. Let's just start drawing our tree like we always do, especially if you've seen my previous streams, you know that I like to use this tool, Excalidraw. It's very easy to use. I like the UI for it. And I think it's just easy on the eyes, especially for the viewers. So that's really nice. Let's fill these in. So we have a 5, we have a 3, we have a 6. Wow, the trash is coming very late today. Interesting. A 2, a 4, and a 7. Okay, sweet. So they want us to see if there are any two numbers, right? Given the root of a binary search tree and a target number k, return true if there exist two elements in the BST such that their sum is equal to the given target. So what we really want to do is we just want to find two numbers that add up to that target, right? And the good thing about our binary search tree is we know there's the main and very important property of the binary search tree, that elements on the right of a node are going to be greater than that node, and elements to the left of the node are going to be smaller than that node. So let's say in this example, we're trying to find 9. So I'm going to take this diamond like I always do. I'll make this sort of our pointer, and this will go, we'll use this to go everywhere instead of our tree here. So let's say that we're looking for a 9. So like as soon as I'm on, I haven't done this question in a while, so this is truly me thinking about this from ground zero. So if we're here, what do we know so far? Well, we know we have a 5, right? Like let's write some things out. We're looking for 9 and we're currently at a 5. So if I do 9 minus 5, then I need to find, right? That equals 4. So I need to go to something that's, I guess maybe whatever the result is. I mean, I could maybe do it based on the result. Like I do 9, or the target, current target minus the number, which is 5. And depending on that value, do I want to go left or right? That's sort of what I'm thinking so far. So based on this, I want to go left because the sum is 4. So then I come over here, and then let's see, I do 4 minus 3. And I can say, well, 4 minus 3 is 1, so I want to go less. So I'll go over here. That's 1, but then we get to a negative number here, which is not very nice. Over here, if I do 4 minus 4, which is the one on the right, I get 0, and that's the answer. So maybe it doesn't necessarily have to be, maybe it's just like we get the current sum and we look at both of the children and we see which one is the one that we want to go to. If I do 9 minus 2, that gives me, or not 9 minus 2, if we do 4, because over here we have 4 minus 3, that's 1. Let me see, 9 minus, oh, and they also don't want us to do target number k, return true if there exist 2 elements in the BST such that their sum is equal to the given target. So do we always have to take, like I say, okay, this is 5, so now I'm looking for a 4, so I can look for this one. So maybe it's just like this, but let's see, because I also suspect that that's a little bit of a contrived example. Here we're looking for a 7. So what is it really that I want to do? How would it be if it was sorted, right? Imagine this was all in a sorted array. We can do what we did last time where we take, not last time, we've actually never done two-sum yet. Let's see. Root is guaranteed to be a valid binary search tree. Return true if there exist 2 elements in the BST such that their sum is equal to the given target. If we do 5, if I'm looking for 28, how can we just start subtracting numbers? I don't think it would be wise to just start randomly subtracting numbers. Let me think about the best way of doing this. Like if I did do that, if I want to find a 28, why would I start at the 5? Why would I just automatically assume I can do 28 minus 5 to get 23 and then search for something else? It must be because the property of it being sorted might be able to help us out here. Well, definitely. Because it's a binary search tree. That's there's no way that I don't want to solve this problem without taking advantage of that property. So I would like to do it in log n time. So if this was sorted 2, 3, 4, 5, 6, 7. Let me make this bigger here. So we have this, right? In the classic two-sum question, we have a sorted input, or that is at least one of the cases that we can get a sorted input. And then from there, we can start sort of, let's see, maybe actually looking at it like this would help. If I wanted to get to 28 and I picked my midpoint here, I'm not really doing a binary search, but I'm saying, well, I'm starting at 5, and now I want to look for numbers that equal. Input is a BST. Return true if there exist 2 elements in the BST such that their sum is equal to the given target. Perhaps we don't actually even need to, maybe we don't even need to care so much about this. This is already sorted, so maybe what we can do is we can pretty much do the same thing we would do if the input was sorted in the case of an array, where I can just look through this. I can look through this and keep track of like the numbers I've seen so far. So I can say like 9 minus 2. 9 minus 2 is 7. Have I seen a 7? No, so I'll store the 7. Then we get to 9 minus 3. Have I seen a 6? No. I can get to 9 minus 4. Have I seen a 5? No. 9 minus 5, that's 4. Have I seen a 4? No. Or rather, no, wait, 9 minus... No, yeah, 9 minus 5 is 4. Have I seen a 4? No. 9 minus 6 is 3. Wait, maybe I'm not doing this the right way. It should actually be the inverse, right? Should I be storing? I should probably put the number here. This should be 2, 3. 9 minus 4 is 5. We put the 4. 9 minus 5 is 4. We have seen a 4. So then that means that we know that there is such a number. That could be one way of doing it. But we're also not taking fact. I mean, maybe the reason that this question is a binary search tree is not so much to take advantage of like the log n solution, but more to take advantage of the fact that it's already sorted for us if we do an in-order traversal. Let me see if we can sort of mess around with that. So let's say we have, let's see, we can create a new set here of scene. Like scene is equal to a new set. And here we want to say if, so if we're like at null, we can return false. If scene.has root.val, we can return true. Okay. Here we can do scene.add of k minus root.val, and then return find target root.left k scene, or find target root.right k scene. So let me just draw this out again and see how it is. So we go through this whole thing over here. Let me delete this, I'll delete this, and this will now be our set that we're going to use. So we start here. If not root, return false. That's fine. If scene.has root.val, return true. So it doesn't. So we just continue going. We add 9 minus root.val. So that's 4. And then we go to the left. It doesn't have 3. So we add 9 minus 3, which is 6. Keep going. It doesn't have it, so we add 9 minus 2, which is 7. Now we go to the next one. It doesn't have, yeah, no, here it does have 4, right? If scene.has root.val, which it does, we can return true, and then we should just finish off with the entirety of the algorithm there. So let's go ahead and see what this will run like. I'm just going to go ahead and run it for both. So we get true and false, and we get true and false with using extra storage, using a set. Let's go ahead and run this and see what we get. Okay, 12.64. So probably this is not the way that we should be solving it. I guess we're sort of taking advantage of the fact again that it's a binary search tree in the sense that it's already sorted, but you're looking at these and we're still having to go through O of n, right? We're having to go through all the different nodes to be able to get that answer instead of taking advantage of a specific property. So how would we, let's think about how we would solve this if, at some point in the future, we're going to do the same question, just given an array. So if we're given an array, one of the ways to do it is how we just did it. And there's also another way where you can start from either end. And you can say, okay, well, I'm looking for a 9, so 2 plus 7. Well, I guess 2 plus 7 is also that. 2 plus 7 already equals that. So let's think about this. It's almost like, when I'm at a specific node, what is going to be the determining factor of me to decide if I want to go left and right? Well, I guess we can say, what if I did like, okay, I do 9 minus 5, and that's 4. So it's less than my current It's less than my current value. So that means I should see if there's anything to my left that's equal to 4. And it says here it's guaranteed, right? Well, okay, no, it's not guaranteed, right? Okay, so it's 4. So now I'm here. Maybe I should look for a 4. But again, like if I'm here, 9 minus 5, well, this is a 5. 5 plus 3, that's 8. But if I add the 4, I just want to do 5 plus 4. I don't want to add this one. So how do I decide whether to ignore a node or include the node, especially in this case? This is the one that's tricky, I think. What if I start all the way in the bottom? 2, 3, 4, 5, 6, 7. If I pick my midpoint, if I tried to do this using like a binary search, and I said, well, I want to find, and it's 2 nodes or just 2 elements. Okay, so I need 2 elements. So if I pick 1, if I ever pick 1 element, like if I pick a 5, then that means that anything that's left to me, oh, wait a second. This is like the node that I'm on is the biggest node, like is the biggest node on this side, right? Like there isn't anything to the left of me that's ever going to be greater than 5. So if I do 9 minus 5, and that's a 4, that means I need to look in this area to check. So that's how I can decide to cut this whole thing off. I think similarly, if I'm looking for 28, if I do 28 minus 5, and that's 23, then I know it has to be somewhere on this side. Because like, even if I had, I guess what's the biggest amount? Because if I do 2 plus 3 plus 4, that's 9. If I add all the elements, but it's only 2. So anything plus this on this side would never equal. Oh, no, that's not true. If it's, because if I had like 26, if I had a 26 adds on the root and then a 22 on the left, or not a 22, if I had a 26 and then a 2, for example, that would work. So what can we do in this case? We have the 5, 6, and 7. We have our midpoint of 5, and I'm looking for a 9. Do I ever consider, like, when do I consider a number versus not? 9 minus 5 is 4. Exists 2 elements in the BST such that their sum is equal to the given target. If I do, what if we use a 2-pointer approach without using a set? Yeah, we probably can, but I think it'd be a little tricky with the recursion to be able to use. You mean 2 different pointers to be able to go to the left and to the right of any given node? If that's what you mean. Two, 3, 4, 5, 6, 7. If I go to the left and that's a 3, I know that I need to find a 4. So that one's less. Well, okay, like, let's backtrack a little bit. Okay, I'm at 5. I need to find, like, I could add any number that can go up to 5. So if I do 5 minus 4, or I do 9 minus 5, that's 4. So I can't do anything over here. So now I go over here, and I'm looking for a 4 now. But am I looking for a 4, or should I do 4 minus 3? Because if it's 4 minus 3, that's 1. I should not go this way, right? I should go that way. Does that mean that I even consider this to begin with? I don't want to come up here and then, right? So Return true if there exist two elements in the BST such that their sum is equal to the given target. Are there any two elements, any two of my children, that if I add them together would be equal to 9? There is a chance that on this node plus the left there can be. And I guess that would be anything greater than 5 you can't. Like 5 plus 6 already, that's like the next greatest number, and that's already 11. So maybe we just pick like, okay, if I do 5 plus 3 and 5 plus 11, if I go this way I get 8, if I go this way I get 11, so let me go this way. Okay. But now what, so I include the 5 now? Maybe that's what it is. Let me see. If I do here 5 plus 3, I get 8, right? And if I do 5 plus 6, I get 11. So I need to pick the smaller of these two. So I'll go to 8. Once I pick it, then I can subtract 9 minus 5 is 4. So now we're here at 4. If I do 3 plus 2, that's 5. Oh, but then that 3 plus 2 is 5. 3 plus 4 is 7. So I mean, it's not that I want to pick the greater one. Four plus 2 is 6. 4 plus 4. Right, left equals 0, right equals nums.length minus 1. Oh, right, but I think the thing is the input here, although it looks like an array, it's not actually an array. I don't know if that's what you meant. Like they have like their own serialization technique where they can take an input array and create a binary tree. But even though it looks like an array, this isn't actually an array. Yeah, there's another, like the real two-sum question is a real array. And that's one of the cases that we'll cover when we get to that question. But yeah, that would make it a lot easier, right? So let's see, because I think we're onto something here. I'll probably go up to like 30 minutes here, and if not, we'll go to the next one. I mean, I'm happy that we were at least able to solve it with the set. That is certainly a way of doing it, but not the best way of doing it, because again, we're having to go through all the different nodes. So if I have a 9 minus 4, there's more information we need to like deduce here. If I have a 9 minus 5, that's going to equal 4. So I can pick, if I pick the left side, that's 3. If I pick the right side, that's 6. Like I can't pick 6 because that's greater than my sum. So I need to pick the left side and then do the same operation again. 9 minus 5 is 4. Okay. So that's why I feel like if I go to 4, if I do 4 minus 3, that's 1. But if I go on the left, 2 is greater than 1. So that doesn't work. And then if I do 4, so maybe I wonder if it should be 9 minus 5, 4. If I do, maybe I shouldn't do 9 minus 5 is 4. So over here I have a 4. 4 minus 2 is 0. 9 minus 3 is 6. 9 minus 6 is 3. If I do 9 minus 5 is 4, and I come over here, now this is 4. 4 minus 3, there's got to be another thing here that I could work with. If I'm at a 5, any number over 5 will never work. So it definitely has to be something that's less than this node. If I'm at a 28, if I'm looking for 28, why wouldn't I ever pick this side? Oh, wait. No, that's the wrong section, I think. Yeah. If I'm looking for the value 28, why would I ever Why would I ever attempt to go down the left side versus the right side? Or vice versa. Why would I ever go down the right side instead of the left side? Can I find two numbers that add up to the target in a sorted array? Definitely can, but yeah, this is... Because right, like what happens, I mean, with the array method, we compare, like we do, let's say this was like, I don't know, let's say we're looking for 10. Let's say here we're looking for 10, right? We would do 2 plus 7. 2 plus 7 is 9. That's less than 10, so we need something bigger, which means we should increase the lower one to get the next biggest thing. So that would be 7 plus 3, and that's 10. But in this case, we only have a single number, which we only have 5. And I say, well, based on this node, how can I tell if I have... How can I tell if I can find a 28? If I had the 3, that will get me to 8. If I had the 5, that will get me closer. Maybe I haven't solved this one before. Maybe it was another one that was like similar. Hmm. 5, 3, 6. This is tricky. Tricky. I mean, and even if I look at both numbers, if I look at 5 plus 3 and 5 plus 6, or if I look at my children and I say, what if I do 9 minus 3? That's 6. That's weird. 9 minus 4, though. I mean, I would say like that's the thing. That's almost the thing that makes sense to me. It's when I get to this node that things become weird. Because I ask myself like, well, I'm currently sitting at a 9. So if I subtract my current node and I get 4, I can't go to the right because this is already a 6. So nothing on this side minus 4 will ever equal 0. However, on the left here is a 3. So I should go there because it's lower. It's the thing that's lower. So then I get here, I do 4 minus 2 is 2. 4 minus 4 is 0. So I go to the lower one. Let's see, 9 minus 5. So is that what I was trying to do before? 9 minus 5 is 4. 9 minus 5 is 4. So go to the lower side. 3 or 6. We'll go to the lower side. And then here we do 4. See, but then 4 minus 2 is 2. 4 minus 4 is 0. 9 minus 3. 9 minus 6. So it only works in this direction. But if we say 9 minus 5 is 4, I need to go to the thing that's less. Okay, so let's go here. Now we're sitting at a 4. 4 minus 3 is 1. Well, 4 minus 3 is 1, and this is bigger than 1. So let me go to the right. Maybe that's what it needs to be. I can do like, okay, let me delete some numbers actually. A BFS, maybe. I'm not sure. Let's see, if I do 9 minus 5, that gives me 4. So based on that, I know that I need to go to the left of 5 because it's like this sum is less than 5. So I come over here. 4 minus 3. 4 minus 3 is 1. But then this is a 2, which means there's nothing on this side, so I need to go to the right. So I think that's how we can start. I think actually that's how we can do it. 9 minus 4 is 3. So we try to go to the left only if it's smaller. Then go left, else go right. I think that's what we can do. Let me refresh this. Is there like a nicer way? No, I'm just gonna have to. So let's do this. Let's do if not root will return false. Here, maybe we can say if k is equal to 0, we return true. And now let's try something else. So const new target, or let's say new k, equals k minus root dot val. So we need to now go to the, so let's do this. If k is less than root dot val, then let's just say for now, return find target root dot left new k, and we don't need seen. Else, oh, I don't know what the heck that was. Else root dot right return and then uk. But let me just like mess with this for a second. So we start at 5. It's not null, and k is not equal to 0. So new k is k minus root dot val, which is 4. So over here, let's say that k is 9, and then new k is 9 minus 5, which is 4. 4 is less than root dot val, so we come here, and now we have 4. Okay, so here we say 4 minus 3. 4 minus 3 is 1. If 1 is less than root dot val, we come over here. But see, I don't even want to go there. Well, if k is less than root dot val, but we should also check to see if maybe this one is also less than the current one, else we come here. But then that means the new k is 1, and then we get here, and then we do 1 minus 4, which is negative 3. That's not going to work. The nice thing to do would be like, we'll do 4 minus 2, and then do 4 minus 4. Do we always want the thing that gets us closer to 0? It's tricky. It's very tricky. But because it's been over half an hour, I was starting a, let me see, follow-ups. Let me do this for a follow-up just so we don't forget about it, because I think it's definitely worthwhile to like come back to. But for the sake of the stream, let's just go ahead and get to the next one. This one we tried yesterday, so I'm just gonna go to this one just to get to like new questions. Let me pop this over here, put this here. Pascal's triangle 2. So given an integer row index, return the row index 0 index row of Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it as shown. So we want to return, could you optimize your algorithm to use only O of row index extra space? So they want to figure out, given an integer row index, return the row index 0, 1, 2, 3. I mean, do we just... They don't want us to just calculate. Is this not just Pascal's triangle, or... Have we already done Pascal's triangle? I'm guessing we have. Maybe. Okay, what was the original one asking for? Return the first num rows. Okay. I see, but here, this is not... Yeah, this is not really, they just want us to use the amount. Is there a nice formula for Pascal's triangle? There's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. I'm going to just assume that there's probably a nice mathematical formula for this that we can just, like, we know it's always going to be, we know we're always going to have, let's see, 1 2 1 row index 3. Can you optimize your algorithm to use only O of row index extra space? So essentially it's constant because row index is just a number. Like O of 3 would just be constant space. Because if I were to call this recursively, then the space would be the implicit stack space, like n times every single new array that we create inside of it to push everything. I don't want to have to necessarily create all, because what you could do is just what we did for the first one. You can create all of them and just return the array at index 3. But that doesn't sound good, right? So let's think about this. Each number is the sum of the two numbers directly above it as shown. And what's the next one? 1 3 3 1. And then we have 1 4 6 4 1, 1 4 6 4 1. How can we figure this out? If at index 4, 1 2 3 4, what would be the next one actually? This would be 5, right? Because 4 and 1, and then 6 and 4 10, 6 and 4 10, 4 and 1 5 and 1. So I think actually, like, a pattern that I'm seeing here a little bit is that, I mean, the first two rows, 0 index 1 and 2, will always have this, but 0 1 2, the second number is 2, and then 3 4. Now when it's 5, this is where it gets a little bit tricky, but like at least these, the first two numbers will represent the number 1 and then the row index, right? So it'll be like 1 plus row index, and the last two will be row index and 1. And how do we figure out the middle? Oh, wait a second. I think I might be seeing something here. This is 1 1 1 1 1 1, but then it's 1 2 3 4 5. I feel like that's not a trivial thing. 1 3 6 10, 1 4 10, 1 and 5. There's definitely a relation between all of these. Like the last one, so last number is always 1. First number is 1. Last number is 1. The second, or is it the second number that we should look at? 1 1 1. That is the last number there. The second one here is the last one. Else, when we have 3, 1 2 3 4 5, 0 1, and it's also, let's write the row number here. This is 0 1 2 3 4 and 5. So here we have 0 1 2 3 4 5. Like the second number in row 2 is 2, second number is 3, the second number 0 1 2. So maybe not the second number, but the second to last number is also the row number. So first number is 1, last number is 1, second to last is row number or row index. So in row index 3, second to last is 3, 1 2 1 4, and also second number is row index. Okay, and now like the third number here, what is it? It's like 1 4. It's 1 4 6, but then I also see sort of like a pattern here where it's like 1 plus 2 plus 3 plus 4 right? What I mean is like this is 1, 3, 6. So it's like 1, and then here we do 1 plus 2, and then when it's 4, do we just do like row index minus 1 plus row index? No, we do, yeah, row index plus, I wonder if it can be something like row index plus row index minus 1. Because here would be 5. Oh, but here, see, this wouldn't be 5 plus 5 minus 1, because that would actually give us 9. Here we want 5 plus 5. Here it makes sense. Could we do 4 plus, or row index 4? No, actually, no, wait. We want 4 plus row index. It's almost like row index minus 1. That's 3 plus row index minus 1. It could maybe something like that. Row index minus 1, 4 plus, so no, it doesn't work there. This is 1 plus 2 to 3, 3 plus 3 to 6, and then 6 plus the current row index to get to the next one. So I feel like we have something here. Like first number is row index, second number is row index. Can we relate this now anyway? Like how do we get to 4? Is it just row index plus 5 to 5 is double, but 4 to 6 is not double? If we do the second one, it might be a little bit clearer. Now we know that this will be a 1 and a 6. This would be a 15. This would be a 20. This would be a 15. This would be a 6 and a 1. One, 4, 10, 20. So you have 1, 1, 1, 1, 1, 2, 3, 4, 5, 6. 1 plus 3, that's a 2 difference. Plus 3, that's a 1 to 3 is 2, a difference of 2. 3 to 6 is 3. 6 to 10 is 4. 10 to 15 is a 5 difference. Here it's 3 and then 6. So here it's being doubled. And then here, what is this being like tripled? 4. But then that's plus 10. That one's even weirder. 1, 6, 15, 20. 1, 5, 10, 10, 5, 10. 1, 6, 15. Let's think of like another 1 plus 6. 1 plus the previous row index. And then row index, row index. How do we get from 6 to 15? We double it and add half. That just sounds weird. From 5 to 10, we double it. Here we just double it. So probably, is it a super fancy equation to be able to get this? Also, can we just like, if we have the last two, is it easy to figure out anything else? Because we know 1, 1, 6, and 1. Because the previous were 5. So then to get to 15, I'm really trying to figure out this like Pascal's triangle thing over here. That's funny. Maybe this is not even the way of approaching it, but for some reason, like we've already made some decent progress. So that's what I'm trying to figure out here. 1, 1, 1, 1. 1, 2, 3, 4, 5, 6. 1, 1 at the ends. 1, 2, 3, 4, 5, 6 at the ends. anything in the middle. Oh, well, the next one and the previous one. Okay, that's fine. And then here, next one and the previous one. And then as soon as we get to the middle, how do we figure out the third number? Like 5 is just 4. 5 times 3, 136. Confused, as always. But hey, this is like, I remember back in the beginning of this daily LeetCode streams, we were flying through questions, and now easy questions are definitely taking much longer, closer to that 20-minute mark per each. Should we go to another one? Should we try and see what else we have here? Let previous row equals get row index -1. Right. I mean, I think there's a way for us to do it recursively. But, well, is that... The thing is, we can, but I also feel like that you can get the previous row by doing let previous row as get row. Well, right, but then what's the base? Like, how do we... Like, we could keep doing that. Will that... Because how is that different than that's what we did here? How is that any different than this one? Yeah, I think the solution that you're proposing is the one that I did for the Pascal's triangle 1, I guess, which is they give you the amount of rows they want you to generate, and then I just go ahead and generate all of them, I think, using the exact thing that you said. Right. Yeah, exactly. But in this case, they're giving me the row index and they just want... So, like, I'm trying to see if I can optimize it by only using row index extra space, because then I feel like here that would be making n amount of calls on the stack, and for each one of those it would have to go to, let's say, whatever the length of that current row is. That's why I'm not sure if that's like what they want for us to do here. Let me go back. Are we still on page 3? Okay, I lost it there. Does that make sense, Rashawn? I mean, at any rate, the crazy thing is we're about to start on page 4. I want to go to page 4. It is confusing, yes. I definitely agree. I think maybe I need to get like a better... Let me change something actually real quick. This is not related to... Let me see something. I need to figure out a way to make the chat box maybe like a different color. There's different themes, so that I can do that later. That one's weird. I want to get to this one too, but I guess we'll leave it incomplete. That way we can remember to do it later on. But we're on page 4 now, which, I mean, okay, this is wild, right? Like, we're certainly not, I mean, we're less than halfway through, even though we're on page 4. Right? Because you would expect if we're starting on page 4, we should be closer to 400 questions complete. Now, a lot of these are premium, so we're not going to be able to actually finish all 591. But you can see that it's getting harder since we're getting further away from the amount of questions that we should be at. But let's see what binary tree tilt has to offer here. This doesn't look like a nice question. Given the root of a binary tree, return the sum of every tree node's tilt. Tilt of a tree is the absolute difference between the sum of all left subtree node values and all right subtree node values. If a node does not have a left child, then the sum of the left subtree node values is treated as 0. The rule is similar if the node does not have a right child. The tilt of a tree node is the absolute difference between the sum of all left subtree values. Wait, what does that mean? Tilt of node 3. Okay, what's the tilt of node? Okay, 5, 7. Tilt of node 2 is 3 minus 5, 2. Oh, so we just come here and then... Really? That's all we do? Wait, so is it just... Wait, let me see something. If root... And this is if it's a... Okay, if not root... If not root, we can just do return 0, I guess. Oh, they want us to return a number? Absolute difference between, so here we do 0, 0, and 2, 7. Oh, we calculate that value, and then at the end we return. Okay, so if not root, return 0. And then why don't we do, let's see. We can say const, do I want to do this by, I guess we can say const tilt is equal to, or I can say left tilt equals root dot left. If it does, then we'll just say, oh, I guess there's no such thing as a root, as a left tilt or a right tilt. It's just a tilt of a node. It'd be nice if I can just go all the way. I think what we can do is go all the way to the left, figure out the tilt there, we'll get some value, and then we'll return that. So let's see if that works. Because I think that'll be better. So we can do find tilt of root dot left, find tilt of root dot right. But that's the thing, we're not actually going to be able to like get a value here. Const left, const right. If not root, return 0. So then we get to the bottom. I understand. I'm just trying to figure out like the best way of going about it. Maybe I can also just process it. However, I don't want to change. I guess I don't really have to change anything. I'm going to do 1, 0, and 0. 2 minus 3 is 1. So I add that, and then I go to the next one. If both the tilt of a node is absolute difference in the sum of all left tree node values. Yeah, you know what I can do? We can probably say const sum. So let's figure it out. We need to get something that's like math.abs of sum.left and sum.right. 2 and 3 become 0 because they have no children, either one of them. So const left node equals root dot left is 0 or root dot left dot val. Const right node is root dot right. Wait, if it's true, we should get root dot left dot val. And I guess we can do, I think we can do root dot left dot val or 0. Yep. And then here we can say root dot right dot val or 0. And then we can say const new sum is equal to the math.abs of left node minus the right node. And then here we return new sum plus find tilt of root dot left plus find tilt of root dot right. Will that work? Let's see. That's 1 and 1. Let's see for the next one. Oh, we're 1 off. Okay, well, we're a couple off here. Let me 1 second, guys. My dog is right underneath my desk, and you know, he's a great dog, but sometimes it's just a little bit uncomfortable sitting next to him. But that's fine. Make it work. Okay, so a tilt of the tree is the absolute difference between the sum of all the left tree node values and all the right subtree node values. If a node does not have a left child, then the sum of the left subtree node values is treated as 0. Right? So then we come here. Now I would like to find one where, okay, here for 9, for example, 0 minus 7. Right, so for any one of these, let's go ahead and draw this. It's very important that we draw this. Let me exit here. We have 6, we have 4, 2, 9, 3, 5, 7. Okay, 4, 2, 9, 3, 5, and 7. Let's do this, and let's see here. Let's connect all these. Okay, so if not root return 0, const left node, so we're going to start over here like we always do. Left node will be, if root.left, we'll get root.left's value, so it's 2. Right node will be root.right, we'll get root.right's value, so that's 9. The new sum will be 2 minus 9, so that's 7 right over here. So we'll do 7 plus find tilt of root.right. So then we get here. They each have a value, so the tilt here is what? 3 minus 5, which is 2. So we come over here. Now we get over here. Left node, right node, and actually let me go back to the drawing here for these leaf nodes. For 3, 0 minus 0, okay, so we get to 3, left node is root.left, no, so it's 0, root.right, no, it's 0, new sum is 0 minus 0, that's just 0, so that's 0 plus the left is 0 plus the right is 0. We come over here, we add 0 from the left. And now we're going to do the right. That's 0 plus 0. So we come over here. We have 2 on the left. That's good. Okay. Let's now go on the right. We're going to do 0 and 7. So that's a 7 for this one. And then we're going to do a 0 and a 0. That's just 0. So it should be 9 and 16. Yeah. Because now this should be new sum 7 plus the result we got from the left, which is 2, plus the result we got from the right, which is 7. Because here we did, why did we get 7 here? Oh yeah, we did 7 minus 0, math.abs, that should just be 7. And we did that plus the 0, we returned the 7, and we get a 7 here, 14 and 16. So where did we go wrong here? We're close. I can feel that we're so close here. Root.left, left node, root.left, root.right, root.left.val, root.right.val, or 0. New sum is math.abs of the left node minus the right node. New sum plus find tilt of root.left and find tilt of root.right. 116 and 7, and we expected 115 and 9. This one, 3, 6, and 0. That 3 is going to be, right, because here we're going to do 6 and 0. That's just 6. Oh, wait a second. This is just 0, 0, 0, 0. We add all the way up here. We come to the top. Are we not also adding, we probably need to add, wait, do we need to add the root itself? Oh yeah, 3 is the 6, so how do we get the 9? Because I don't see any number. Oh wait, 6 and 9, and then we add the value? So we get the tilt, 6 and 0, math.abs of 7 and 14. That should be 7, no? This is so weird. I'm looking at this tree right over here. So 21, 7, and 14, it says that return the sum of every tree node's tilt. The tilt of a tree node is the absolute difference between the sum of all left subtree node values. Oh, and all right subtree node values? It wants us to add everything first. Tilt of node 4 is 3 plus 5 plus 2. I see. Okay. We need to do this the other way. We need to go to all the children first, returning the sums or returning the tilts, and then using previous tilts to come up with new tilts, I guess. Or the sum, or just the sums actually. Yeah, we have to add everything. Right, exactly. You're right. And then whenever we get to a value, yeah, we go all the way to the left. If it's, let me think about this. If we go all the way to the left, so 4, 2, 3, we come over here, we get 0, we get 0. Now we're at this number. This is the sum, absolute difference between the sum of all left subtree node values. So it's almost like we're 3 plus 5 plus 2 minus 9 plus 7. 3 plus 5 plus 2 minus 9 plus 7. So we should just have the sums of each. So it's like we get the sum of left subtree, get the sum of right subtree, and then return math.abs of left minus right. It's almost like that. But how would we... The tricky thing for me is like, how do I return both of that? How do I return like both pieces of that information? Like I need to get the current sum that I've already gotten. I guess what we can actually do at the end is just return. We can return the root. Actually, will the root be that? This is 15. Or maybe not the, yeah, I think maybe what we can do, here we can do 3, 5, and then here we can just do 3 plus 5 plus 2. And at the end, we'll just get the sum of all the trees, but that's still not going to be tilt. Oh, 1 second. My dog is tilt plus or equals math.abs of left minus right. Return left plus right plus node.val. But wouldn't that be processing the node first before getting any of the children? I think if we did it that way, that would be like a pre-order traversal, where I would need to get math.abs of left minus right. But what if I actually changed the value of the node here? I can change the value of the node. Like here, I'll say, well, like what if we did, okay, this is 3 and 3, so this is just, this becomes a 0. This becomes a 0. And then we're here. No, but we still need the sum. We would still need the sum here. So maybe... Yeah, we still need the sum. Tilt of node 4 is 3 plus 5 plus 2. Tilt of node 2 is 3 and 5, which is 2. But that's the thing. It's like we're figuring out the tilt. We figure out the tilt. So like here, we do 0 and 0. And then add that. Then here, it's just 0 and 0. Do we add that though? Math at opposite 0, 0, and 0. So if I set this to be 0, I feel like I'm so close and I'm making like a really dumb sort of like decision here. Because like, what if I set any one of these nodes values to be the tilt, and then I get over here, I can figure out the tilt from here, but this is also 0 and 0. So does that mean that this is 0? That doesn't make sense. Tilt plus 0. I think maybe it's, let me see, then tilt the absolute difference between left subtree and right subtree, return left plus right plus node val. Yeah, it's almost like get the tilt, return the tilt, get the tilt, return the tilt. Can we just add up every intermediary sum? Like, oh, I'm so confused about this one. So confused about this one. 3 minus, I mean, it's a classic. I can see the recursion, and I can't, oh, sorry about that if I kick my desk a little too much. We're trending a little over the hour, and I like to keep these below the hour mark, so it's unfortunate that we couldn't get to it, but nice. I don't want to see the answer yet, though. I need to figure it out for myself, but that's cool, though. That's good. It's really good. Yeah, I need a little more practice with this one. I'll have to like, and I know I'm, oh my gosh. I spent two more minutes. See if we can do it. Sum of all left. Tilt of a tree node is the absolute difference between the sum of all left subtree node values and all right subtree node values. Get the sum of the left subtree, and then return math.abs of left and right. This is the sum of that subtree. I mean, if we do, wait a second, if I just get the sum of all these numbers and then at the top, like 3 plus 5 is 8, that's 10, 9 and 7 is 16, and then 10 and 16 is 6, 4 plus 6, no, that's not going to work. Here it's just the addition of all the left subtree, sum of every tilt, where the tilt is the absolute difference between the sum of all left subtree node values and all right subtree node values. So here it's 7 and 3, that's 11. 7 and 3 is 10. 9 plus 7 is 16. 10 and 16 is 6. So that gives us this root, but it doesn't give us the intermediary roots. If I have a sum from here, this is 0 and 0, so I leave this as 3. This is 5 and 0, 0, so I leave it as 5. This is 3 and 5, so I leave this is 2. 0 and 7, so this is 7. Then I get here and I do 2. I guess by the time, so it's always going to be left and right, but we have to, yeah, we return the left and right once we've already set it. So we can go all the way down, or maybe not. Maybe we don't need to go all the way down. No, yeah, we do, right? Because it needs to be all the left subtrees. So we need to go all the way down. We need to go all the way down to the left, get the value of the leaf node there, which is a 0, and then that's a 0. So maybe let's see if we can start messing with this here. I'm just gonna start writing some stuff. Like if not root, return 0. If this is a leaf, so if not root dot left and not root dot right, maybe we just return 0. And then here, the tilt would be the absolute value of left. So if, but then, I mean, would it be const tilt equals math.abs of root dot left minus root dot right? But then, why is this so complicated? Return left and return tilt. But see, I'm also not, oh, we can also say root dot val equals tilt. And then maybe here we can say return tilt plus find tilt of root dot left plus find tilt of root dot right. Can we set the val to be the tilt so we can use that value later? Oh. But then if we set the tilt to be 0, how would that, if I set the tilt to be 0, that doesn't immediately make sense to me why. It doesn't immediately make sense to me why that will work. Hey, what's up? Big task at hand. Yeah, it's going all right. Just a little bit confused about this question, which is probably a really dumb question, but you know. And it looks about as much because this like to dislike ratio is not good. The tilt starting value has to be 0. But if tilt plus, let's see what this is. Okay. Yeah, it just doesn't, like, at least here it doesn't, because shouldn't it be, well, okay, const tilt is, yeah, so really I need to like go all the way down first. I need to go all the way to the left first before doing everything. This live stream just popped up on my recommendations. That's awesome. Are you on Twitch or on YouTube? Because tilt of the current node is 0. Yeah, YouTube. Nice. That's awesome. Thanks. Yeah, thanks for joining. Appreciate having you around here. Yeah, I've been doing this for a while, and today was like a so-so day. I think we started off pretty strong, but then some of the other questions we got were confusing. So you'll see that with these live streams, I'll have like really good days, and then other days where I'm just like confused completely. So the thing is, it's funny because you'll see all these lists of like, oh, grind 75 and blind 75, and like people can just do those questions really easily. But then I get presented with something completely new, and it becomes like really, really tough. That's awesome. Thanks so much, Big Task. Yeah, I think, and it's funny that you just I know you just came into the stream, Big Task, but I normally try to keep these streams under an hour so that people watching can just sort of like, they can just watch it for an hour and they know that every day there's just like an hour they have to listen to and like nothing more. So this might be a question that I revisit later. Is there perhaps something else that we can do to finish off on a strong note? This looks like a bad question, so can we get one that's like high quality? Maybe this one. Given a string S, return the length of the longest substring. Yeah, I think this one, Rashawn. I know that you. Oh, nice. Thank you so much. I don't know why. It doesn't always work, but I should have seen. There should be like an alert that comes up on the screen that says that you subscribed or something. But I don't know why. It doesn't like always work. But I really appreciate it. Thank you so much. Yeah, this one, Rashawn, I think I'm going to leave it for like a weekly roundup or towards the end because I think I've spent too much time on this one. So let me see if I can go over here and finish off strong. So given a string S, return the length of the longest substring between two equal characters, excluding the two characters. If there is no such substring, return -1. A substring is a continuous sequence of characters within a string. So optimal substring here is BC, CBZ, XY. Okay, so max length between equal characters. So like we need to find the positions of any time there are two equal characters on either end. And then I guess we can just compare the distances of those. And it says, given an S, return the length of the longest substring between two equal characters, excluding the two characters. CBZXY, because there's never two characters. So I think one way to do this, let's think about this. The weekly roundups I switched to be every single Sunday. So like if you come over here, let me refresh this. 335. Love seeing that number go up. So we need, let me see, we need 115 more to be able to unlock the community feature, which will make it much more easier for me to communicate with everyone. Like once I unlock that feature, then I can just start writing posts and taking polls and really getting like great feedback. But weekly roundups are every Sunday. And I just go, what we do during weekly roundups is we just go through all the questions from like previous questions, and we just try to see, we do the ones that we either couldn't finish or just like new ones to kind of like try and even out the amount of questions we've done. So I feel like for this one, we definitely have to find two unique characters. We have to find all the different places where there are two unique characters and then get the longest one. Because we can have something like ABCA XYZ XCYA or something. And like even though there's an A and an A here, there's also an A and an A here. So I feel like the longest one should be this one. So how can we find that? I almost feel like Sundays, normally on the weekends, I just do it whenever I wake up. I don't have like a set time because on the weekends, if I feel like sleeping in, I probably will. But you can almost, if not, if like you don't catch the live stream, you can always just watch it on YouTube. I always like put the streams there. So this one, I feel like it can be a combination of 2 pointers starting from either end, but there's a chance where, because I've tried to do questions like this before where I have, let's say I have like a D here or something, and like it's not clear to me why, like, okay, if this is an A, I'm just gonna start from the end and look for the first A and then calculate that distance. But like it needs, I feel like it needs to be something else, because I feel like doing it this way we can miss some characters. Like maybe D is actually the longest one, but since we were only looking for A, we never got a chance to look at D. So I wonder, the optimal substring is AA. I guess what we can do is we can have like start and end positions, and then we can also have like the longest start and end positions. What if we had like a couple of different data structures where we had or we can have like a max length and also a sort of like positions array, where for every letter we have an array that represents the current index and like the previously seen index. So what I mean is this. So let's say max length is 0. And what we can do is I can say for let I equals 0, I less than s dot length, I plus plus. There's a couple different things that can happen. Like if, let's just say, I'm going to comment this out so you can see it for reference. Let's say positions equals an object literal. Here we can say if positions of s of I is equal to undefined, so this means that we haven't even seen this character at all, then that means that we can do positions of s of I is equal to an array that just has I. Else if, let's see, else if positions at s of I, well, I guess what's the other case? If it's the first time, we'll add one. Else if it's already defined, let me see, if it's already defined, then I just want to set the position. I just want to set the second position. I can say something like positions of s of I at 1 is equal to I. But this brings up a couple of different things here. So any single time that we see one, let's see, the max length, or I guess we can always take the max length once we find. Yeah, I think what we can do here is anytime we find a new I after the first one, that can be a new distance that we calculate. All right, so by the time we find the second one, it's, let's see, 0 and 4. So if we do like the length of this one minus, so if it was like, let me see, yeah, 2, we found one at 1 and we found one at 0. So we should do 1 minus 0 minus 2. Well, that's 0. The optimal substring here is an empty substring between the two A's. Here if it was 0, 1, 2, 3, 3 minus 0, that's 3. Yeah, how do we get everything in between 3 and index 3 and index 0? Like the inclusive range of those. Is there like a, man, I can't believe I'm even asking that question. It sounds like such a dumb question to even think about. But if we have like a 5 and a 1, I just want to somehow get 3 to get like 2, 3, and 4. Is there a nice way to do that? I'm sure there probably is. Get amount of elements in between two indices. You guys know what I mean though, right? Like if we have 3 and 1, I just want to get the answer 2. If I have 0 and 1, there's nothing in between that. So get amount of numbers between two numbers. So like get amount of numbers between two numbers. Count number of values between two numbers. Is this like a nice formula to do this? Larger minus smaller minus 1. Okay, so 1 minus 0 minus 1. 5 minus 1 is 4 minus 1. Okay, there you go. So yeah, I think what we can do here, you see, I learned something new. Like that's not, I mean, I probably could have derived that myself, but I'm happy that I looked it up anyway. That's fine. I'm all for that. I think what I'll do here is anytime I find a new I, what I can do is I can say max length equals max.max, math.max of max length, or let me see, before, so I add the new one, or I check the current one of 0 or the current thing. And the current thing is going to be whatever is, let me think about this. I have A, B, C, A, I see it. So I can calculate that distance with whatever is at I. I think I can just set, yeah, I think I can just set positions of I, like immediately. I can do this, and then we can say it's equal to max, or let's see, this is the, let's do something better. So let's say const first position and second position, or we can say const start and end equals positions of s of I Okay, wait, I have a better way to do all this. We're going to figure it out right now. Else, here, we'll do this. Else if positions of s of I, if it has a length of 1, then what we'll do is positions s of I dot push I. Else, we'll do this thing. Const start and end equals positions of s of I. So we'll get the current start and end. We'll say, let me see, when I push I, what do I want to do? I guess we can start, I guess here, if positions s is I don't think we need to do anything there. So let's come over here. Start and end equals positions of s of I, and max length is equal to math of max length. Now there's one piece I'm missing here. I'm going to get to that in a second. Max.length is math.max, or here we can do n minus start minus 1. But what I need to do is if we haven't seen it, we'll set the start position, which is just I, create a new variable, create a new array at A. If we see it a second time, we'll just push it, so we'll get 0 and 1. Else, if it's greater, then here we'll just say positions of s of I at 1 is equal to I. We can just do this. And then after that, we'll just take the current max length, math.max of max length, or n minus start minus 1. So the way that I see this working, so now if we go through the whole thing, and let's say we're starting with A, B, C, A, right? Like we start with I at A, right? So right here we say if positions of s of I, which is A, is undefined, which it is, we'll create a new key with A, and we'll set it to a new array where I is equal to 0. Then we get to B, we do the same thing. So now we say B is equal to 1. Then we get to C, so that's 2, right? You guys see how I got that so far? And then when we get to this next one here, A, we'll say if positions of s of I is equal to undefined, it's not. So then we'll come here and we'll say if positions of s of I dot length is equal to 1, which it is, then we'll just push the new I, which is 3, and then we'll get start and end, which is positions of s of I. So start is 0, end is 3, and we'll say max.length equals max.max of max length 0, or n minus start 3 minus 0 minus 1, which will give us the answer of 2. Now, if we have, do I always want to keep, I don't think I need to mess around with start. Oh yeah, maybe I don't. So maybe there might be a case where I need to though. But here, if I had like X, Y, Z, S, F, A or something, I'll get all the way to this A, and I'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I'm at the new A. I change that to 9. And now I can set that equal to 9, but it says it has to be between 2 equal characters. I guess that's fine. If there's no such substring, return 0. So if there's never a substring, if I never find 2 unique characters, I guess, then max length will never change. because max length will only change if I've already set if I ever get to a point where there's duplicates. So I think here we can say return max length equals 0. We'll say -1 else max length. That's what I think. So let's reset positions here, which we already did. And let's try this out. Pretty unique question. Okay, so we have a 0 and a -1 here. So let's see why that happened. Max length equals math.max of, so we had 2 here. So if we have AA, for I equals 0, I is less than s.length. If positions of s of I is undefined, then positions of s of I, which is A, is equal to 0. Then we get here. If positions of s of I is undefined, which is not, if positions of s of I dot length equals 1, we're going to push the new I, which is 1. Then we'll say const start of and end of positions s of I, which is just 0 and 1. We'll say math.max of 0 or 1. Oh, wait, what? Expected 0. Oh, because it also wants it to be, yeah, math.max of max.length. So it's actually, it's not so much that max.length is 0. It might just be 0. Should we set max length to be -1 then? Maybe that would be easier if I set this to be -1, because then the first time we come around, 1 minus 0 is 0, minus 1 is 0, and that is greater than -1. So here it can just be a maxed out length. Yeah, and that trick right there, Rashawn, like setting that to -1, I don't know if that's like a trick per se. I just messed up with this, but I like to think it's like somewhat clever to do. It's like when you create a for loop that starts at index 1 to handle the case where the input is an array of size 1. You don't even need to, you can change the way the for loop works instead of having to write a case to say only do something if I'm dealing with an array that's larger than size 1. Okay, so that's that one. Let's see the other ones. 0, 2, and -1. All right, I mean, we passed the cases, so let's see if it works. Okay, nice. Yeah, this was a very cool question. I really like this question. This is nice. And we can maybe, let me see, because I know I always say it, but I know there's people out there that really like ternary statements. Make this look a little bit maybe cleaner. I guess cleaner is that's an opinion, right? All right, this positions equals I. Is there anything that we can do here? Const start and end equals positions. I think this is pretty good here. Pretty happy with this. Now, what? Let me see something. We're only dealing with lowercase English letters. So you know what? I might not even need to do. Probably what we can do, let me see, 0 and 1, if I've already seen. I guess it'll always be, we always have the start. The start should always be if it's non-zero. I'm thinking of another way of doing this that we can maybe improve it, because we're only dealing with lowercase English letters, which makes me believe that instead of using positions, we can create an array of size 26. Let me think here. No characters that appear twice. Because if we have, like the first time we see the character, we can update, we'll update the value or not. Oh, but there's a chance where it can be 0. I mean, I could set every index to have an object similarly to this. and I could essentially do the same thing using an array. Now, if we only knew, we can also get the start value. Let me see. What if I loop through the array once and I get all my start values, and then I can loop through the array a second time and just get all the values. Let me see. Loop through the array a second time, and if I ever come across a value that's not equal to the start value, I can calculate the max that way. Yeah, I think I can do something different here. Check this out. Let's check this out. So I'm going to keep all this stuff the same. But this time what I'm going to do is I'm going to say const starting indices is equal to a new array of size 26. We'll fill that up with 0. Then what I'll do is for let I equals 0, I less than s dot length I plus plus. So here, how do we know if we've already seen this value? Because there's a possibility, like a 0 does not necessarily mean that I haven't seen the value before. Because in this first one, if I is equal to, let me see, if start indices of I, or I think maybe we need to get, let's get the index. Let's get car code, s of I dot car code at 0 minus 97. Do minus 97 so I can map lowercase letters to their respective indices. And then I think what I can do is say if start indices at car code is, if it's equal to I, so if it's equal to 0 or, because I only want to get it the first time. Like when I come to this second A, right? I'm going to try and see like 0. Have I already been to 0? Yes, I have, because that's where the first one is. So how would I know that I've already seen that one? If I get to B, have I already seen that one? Yes, it starts at 1. So this only has my starting indices. Because what I want to do is, like, I want to only get my starting indices, and then I'll loop through it again from the back and then just compare. As long as I'm not looking at an index, as long as my I is not the starting indice, I can redo that math.max calculation. So A starts at 0. I mean, what I could also do, wait a second, I can make this easier and just do -1. I can fill this up with -1, right? And then if start indices at car code equals -1, then we can say, yeah, if it equals to -1, then I'll just set start indices at car code equal to I. So I set this equal to -1 to signify that I haven't seen that character yet. And I can do s of I car code. So here I'll say if start indices at 0, which represents A, is equal to -1, then I haven't seen it, so I'll set it equal to I, which represents the ith position of where I currently am, and that's it. Like, I've already seen it once, so the next time I get to it, like I get to a number 1 here, but that's still 0, so I don't change it because it's no longer -1. I think that could work. And then what I can do here is I still have my max length. This time I'm going to declare max length down here. And we can say for let I equals s.length minus 1, I greater than or equal to 0, I minus minus. We'll do the same thing with car code again. And now I only need to do if start indices of car code is not equal to -1, and it's also not equal to the current ith position where I am right now. If it's not equal to -1 and not equal to where I am currently, then I can do this same calculation up here and say max.length is math.max of max.length, or we'll do the end, which is I minus start indices of car code -1, return max length. I think this might work. 0, 2, and -1. Submit. 28.44. Was that even better than the other one? Maybe not. I just feel like it uses less, like here, since, I mean, object literals are stored on the heap, and it's more difficult for the compiler to optimize for that, since we never know like how much space we will eventually need, whereas with something like an array, I can just declare that size, you know, that space once, and I just know that I'm only ever going to be using those many blocks of memory. So the time complexity is still linear, although to be fair, now we're having to go through S. Maybe I don't even need to go through S here. No, yeah, we do. We definitely need to go through S. Oh, at any rate, even if this is not better, I'm glad that we still went through this. I think it was a cool exercise. And this is the thing, like for people that are listening, right? I felt much better about this question, even though the time shows that maybe we're not doing so well. But I felt much better about this question than I did about the binary tilt question. So some questions you're gonna like know how to do well, and other questions you're just probably gonna struggle more with, and that's fine. Like that's just part of the struggle. So let's see what discussions have to say. We can probably learn a lot from here. All right, so store the first index of the substring between the same characters if current character was seen before. Compute the length of the substring between them and update the max length. So it sounds very similar to what we did. Max length is 1. If idx s.car x, so if index idx is greater than 0. Oh wow, that actually works nicely. We could just use a single one. Yeah, they combined everything into a single step, which, yeah, you could do, right? You set it equal to I plus 1. And then whenever it's greater, you can just take the max length and continue calculating it that way. Nice. I think that both are fine. I mean, it's cool condensing everything into a single for loop, but I think both of these ways are fine. And we also sort of did it like this here. Instead, I mean, their solution is sort of a mixture of doing this plus using an array. We sort of did it in two different ways. But anyway, this stream has definitely gone much longer than I normally do, but one of the reasons I did it is because it's currently raining. I like to normally go on walks after these streams. It's sort of my time to decompress, but it's raining pretty badly right now, so no walk for me today, and that's fine. But we did, let's see, I think we did like 3. Wait, we only did one question? Really? Did we only do one question? Largest substring. No, we definitely did 2. I don't know why it shows us only 1. It should be 246. That's odd. That's weird. Could have sworn. Well, I think we only completed 2 questions. Maybe we went over 4, but only completed 2. So thank you all so much for watching. Again, just like a quick sort of update. Like, as for the people that have been following me for a while, some of you know that I have no, some like I do these daily LeetCode streams every day. Obviously, that's what daily means. And I do weekly roundups at the end of every week on Sunday, which means that we just go back to previous questions we couldn't solve, try to redo them. More recently, I started doing front-end projects that I just implement using vanilla JavaScript, since I'm a front-end developer and I enjoy using JavaScript. And even more recently, as of last night, I started creating playlists that I'm going to start doing for all the different Explore cards. So the first Explore card I did or am doing is called the LeetCode Beginner's Guide. And that's just a way for you to see videos that are specific to a single problem. So whereas the LeetCode daily streams are more like a podcast long form style, these questions are if you're looking for just a single video to explain that question and you don't want to listen to anything else, because I realize there's a lot of people that also want that sort of content. So I wanted to put that out there. So thank you all so much for watching today. I really appreciate the support. We're at 335 subscribers and counting, so always getting better every single day. I really hope you are all also appreciating these videos as much as I enjoy making them. Hit the subscribe button if this is your first time here. Follow me on Twitch. Do all that good stuff. We'll see you again tomorrow at 5 p.m. Actually, tomorrow I might do it a little bit earlier. I'll wake up earlier and I'll set the stream for a certain time. And for everyone that's subscribed and notified, you'll see a time. But I'll probably do it before 5 p.m. So see you guys tomorrow. Have a nice rest of your day and happy coding.